Welcome to Cryo Talk, a bite-sized bio podcast sponsored by Thermo Fisher Scientific, featuring conversations between your host, Eva Amson, and experts in the field of cryo-electron microscopy.
Today on Cryo Talk, we're joined by Joachim Frank, Professor of Biochemistry and Molecular Biophysics and of Biological Sciences at Columbia University, as we discuss his Nobel Prize-winning discoveries.
It was a very instant glimpse that this could be used in image processing.
His second career as a fiction writer.
It's a novel about a scientist, of course.
Why he loves living in the Berkshires.
So they're very interesting people from all fields of science and arts.
And the importance of always using your peripheral vision.
You just don't know what opportunities come along.
All in this episode of Cryo Talk. Hello, I'm Eva Amson, and I'm here today with biophysicist Joachim Frank, professor at Columbia University and recipient of the 2017 Nobel Prize in Chemistry for his work on the early development of cryo-EM. We're going to talk a bit more about that later. But first, Dr. Frank, how are you today?
Fine. Thanks very much for having me.
We're glad to have you on the podcast. Can you tell us a bit about what you're currently working on, or what your group is currently working on?
There are a number of time-resolved cryo-EM projects. This time we're working on eukaryotic translation, different steps in eukaryotic translation. Previously, we worked on E. coli translation, and so this is a major switch.
Yeah. Sounds really interesting to really figure out all the mechanisms behind it. And as I mentioned, you got a Nobel Prize a few years ago for work that you did many years ago in the early development of cryo-EM, and that work was in the pre-cryo-EM days. So can you tell us a little bit about how that connects to what now people know as cryo-EM?
Well, this was very interesting and exciting. Pioneering time when we had to make do without a very, very good means of supporting molecules. So we used a negative stain, and negative staining is really not a very good method to preserve 3D structure. And so it was a great challenge from that point of view. Nevertheless, we essentially got it done. The trick is, I think, with negative stain, that you choose sections where you get a full coverage with a stain, so that you can get at least a preservation of the entire structure. Even though it's distorted, it's always distorted. It's always collapsed in the Z direction.
So it's a lot easier now to image than it was for you back in the days.
Yeah, absolutely. And so this is actually, that's a major challenge in with the whole idea of single particles, because since the molecules are not sitting together. Mm-hmm. They cannot, they're not sort of fully stained normally. Yeah. So each molecule is individually stained, and each has its own way of getting stained, so there's a lot of variability. And that actually was interesting, because that variability was interesting from the point of view of looking at the multivariate statistical aspect of it. So it's possible, at the time when we developed the multivariate statistical analysis, which was 1980, 1981, the first really very dominant thing that came out when we looked at molecules in stain is a very big variability in stain distribution at the periphery. Mm. So you get some you get molecules on one side that are only halfway in the puddle, and the other ones are completely immersed.
Wow.
That's a very interesting aspect of heterogeneity.
Yeah. So and your work from around that time was very much about like being able, I guess, to average the image and get a sharper picture. Am I summarizing that in a way that makes sense?
Well, the two-dimensional proof of getting much enhanced two-dimensional information was the first proof of concept. Yeah. So the proof was to get successful alignment of images, and then that was essentially the first thing. We could get sharper information out. But then the next step was, which was really a real milestone, is to be able to differentiate between molecules that have different appearance. And then so then you get really very sharp images of subsets. And that was a big breakthrough. And I think, in terms of credibility of the entire method, that really made a very big difference.
Yeah.
So that happened in 1981.
Yeah, and I mean, if you think about what people are looking at right now, it so often really is about distinguishing the tiniest little differences, and
right.
So there's a lot of information in that. So over the course of your career, you've worked in Germany and the US. Can you take us very quickly through that journey?
Well, it was a very big, very long journey. I was first at the University of Freiburg and got my Vordiplom, so it's the bachelor, and I majored in physics, and then I went to Munich and did a master's at a place. At the Rollwagen Institute, where I worked on a project of looking at the backscattering of electrons on liquid gold. So that was a very big experimental challenge, because you had, if you can think of it, you have to keep gold at a melting temperature in vacuum, where you also do measurements of backscattering of electrons. So this was an incredible experimental challenge. And then, but that introduced me to electrons, and electron. I had to build a little electron gun in the process. So that sort of steered me in that direction. But also the mentor that I had, Dr. Kinder, was one of the pioneers in biological related electron microscopy. He discovered the patterns of scales on butterfly wings in 1943. So which produce color by interference effects, and so he had an instrument, an old electron microscope in his office that looked like the cannon of Peters moon shot. It's a children's book. It was mounted. horizontally, slightly coming up to you, to the observer. So the screen was in front of you, and the cathode was at the very far end.
And how big was it?
Well, it was a normal column size, but it was mounted slightly upward, horizontally, facing you. So then, since I wanted to stay in Munich, I had to find a place where I could do electron microscopy. So that's how I wound up with Hoppe, Walter Hoppe. So Walter Hoppe had an institute for structural research, but he was an X-ray crystallographer who discovered an interest in electron microscopy. So he applied all the different concepts of X-ray crystallography in electron microscopy. So there's a lot of work a lot of theoretical work that he did at the time. It looks very esoteric if you take a look at it. It's very, very esoteric. He had incredibly high-flying ideas, but they could not be realized at the time. Many of them could not be realized at the time. So that's how I spent time, and that's where I got into image processing. I did the first image processing for micrographs, and discovered that one could use correlation functions in order to get alignment of images, and found out all kinds of theorems. I studied statistical optics and applied some of the theorems in image processing. And so that was really the beginning. And in 1970, I got a PhD. And in the process, I got a nomination for a Harkness Fellowship that brought me to the United States for 2 years. And I could select any labs that I wanted to go to. And so I wound up at the Jet Propulsion Laboratory first, and then I went to Bob Glaser's lab at Berkeley, and then at Cornell University. And a very interesting time was at the JPL, Jet Propulsion Laboratory, because at the time they had the most advanced image processing equipment in the world.
Oh, wow.
I could do scanning and also making images again from the computer, which nobody could do anywhere. We did overprinting of characters before that.
Wow, yes. That must have been so interesting to be at a place that was really at the forefront of technology.
Yes, and I used the image processing system Vicar. I didn't use it, but rather I use it as an infrastructure to port my programs in. And so I had an entire infrastructure which did pseudo do loops and things like this. So I sort of hooked my programs up, and it was very very advanced kind of way of using software. And then later on, these ideas that I found in the software development, I applied in the development of Spider.
Has there ever been a moment at any point in your research or career where things took a surprising turn for you?
Always. Yeah. I told you about how I ran into electrons and electron microscopy, and And I wound up with Hoppe only because I wanted to stay in Munich, because I thought it was an interesting place to be. And later, there's a story about the multivariate statistical analysis that it was a sheer accident how we developed this, and it was spurred by somebody working in blood sample analysis, and because multivariate statistical analysis had been used for a very long time for this kind of for specimens, medical specimens, and so there was a very instant glimpse that this could be used in image processing, and so that was very exciting.
Yes, it's funny how things end up. Like you make a choice for one reason, and it ends up completely defining the course of your career.
Right. That's why there's a lot of I got a lot of questions from students. Is there something special that you want to convey to us? What how can one be successful? And then I always say peripheral vision. Keep the peripheral vision open. Don't just follow one specific plan, because you just don't know what opportunities come along, and you just have to keep a very open eye.
Yeah, that's definitely true. And if we go back to cryo-EM for a bit, is there anything that you're very excited about where the field is going at the moment?
Well, the fact that we are now getting something in the 2 angstrom range, if we do things right, if the sample behaves right, that's very exciting, because then really cryo-EM can contribute to drug development and so forth. It's really the right direction, and I don't know what the purpose of going to 1 angstrom is. It becomes more esoteric. And then so lately, I'm really very interested in the cryo in the time resolved technology. I've contributed to it, and I think it's probably gonna become mainstream when the kinds of instrumentation is generally available. And so I'm working myself on this. I'm working in collaboration with a company to make that happen. And we're trying to get into a price range where it becomes competitive.
Yeah, it's definitely exciting times also for I guess people will be able to use it for so many more applications.
Right. And then the other developments that I've been involved in is the mapping of conformational space and state space, and to map the free energy landscape of a molecule. Wow. So that's it's a very fascinating aspect of cryo-EM, because you get such large ensembles of molecules. You can get millions if you want to, and then a deep data analysis and machine learning can give you a sense of the conformational variability, and you can then analyze it to get free energy landscape. And from there, you can explore the functional movements of the
Mm.
molecule.
Yeah, wow, that sounds like something that's like thinking back to my own days of studying chemistry and biochemistry. That just seemed completely impossible, and that's the
Yeah, I have a. I mean, if you want me to just illustrate this with a few words, my favorite example is if you. I found an image. It was from somewhere in China. There where 10,000 horses were galloping over, through a landscape, and of course one couldn't see the 10,000 in this picture. It's just this subset, but you could see them going into the horizon. And then just imagine you have somebody standing somewhere, a tourist, and he takes pictures, and it takes a whole lot of pictures. Or in fact, you have many people standing there, and they're all taking pictures from that direction. So then the challenge is you go home, and now you try to sort these pictures, and they're all galloping. So you should be able to get for each horse picture that you have, there's always an before and an after one of any other horse. Okay, so you can order them in the sequence of gallop, and then so you can actually extract from there an entire sequence, the entire work cycle of gallop from all these horses. So that's really what one can do if we have some conformational movement of molecules which are multidimensional, and then you can order them. You can order them in the different dimensions, and then can in the end get information about work cycles and so forth.
Wow, that sounds amazing. So we talked a bit about what you see, where you see the future of the field going, but what about yourself? Do you have any plans for the next few years?
Well, I was very lucky to get another big grant, and so I'm gonna be able to realize a number of my dreams, in terms of time resolved cryo-EM and so forth, the next 4 years, and that's pretty much my sort of the milestone of retirement, probably.
So one big project before you retire. And I understand that you're also a novelist. Can you tell us a bit about that?
Well, I've been dabbling in fiction writing for a very long time. I got very excited when I discovered that I can really write English as a second language in a way that would be recognized, and I was able to publish short stories and so forth, and then I have written a number of novels, and one of them has been published in 2019, and so it's available now. It's called An See, but it's really I wrote it a long time ago, and had to rewrite it very often, and it's fun to read. I think it's a novel about a scientist, of course, but it doesn't have a lot of similarities with me, but it benefits from the whole knowledge that I have about how science, how the heads of scientists work, and what makes them excited and so forth.
Yeah, and is it did you start writing as kind of a distraction from research, or do you see writing fiction and thinking about science as somehow using the same creativity? Or?
Yeah, I think so. But at the same time, I would be unable to confine my whole being to science.
Mm-hmm.
That's impossible. I really need this as an, I wouldn't call it distraction. It's rather a sort of a complement of my whole existence.
Yeah.
Yeah.
And can you tell us a little bit about the picture that's behind you at the moment?
All right. Well, this is a picture. It's a collage that's supposed to look like a butterfly, and it was done by it was a present by my daughter when she was in high school. It was one of the projects. She did really absolute beautiful things. She started drawing amazing things when she was little, when she was maybe 10 years old, and so on. Beautiful things. I have a large collection of these. And then in high school, it became much more elaborate. And then I always thought she would somehow get into area of art, but she didn't. She got into linguistics, and now she is in a code in a code academy. So she is at a place where she develops curricula for code developing. Yeah.
So you've always encouraged your children to be creative.
Oh yeah. That's really, because for me, this is really sort of the essence of my day-to-day existence. I really enjoy looking at things. I enjoy taking pictures and bring them into contexts, in different contexts. I enjoy the juxtaposition between images and texts. That's very, there are essentially three ways how you can explore this. One is that the image is an illustration of the text, and the other one is that the text is a legend to the image, and the third one is that you take deliberately two completely unrelated image and text together, and then you find out that in the person who looks at it, you immediately start getting a new gestalt from this. They're immediately seen as in some way related, and that relationship is sort of created in your brain. And so this kind of exploration is very exciting to me.
Yeah, and I guess people don't tend to think of science as being creative, but it is, of course, very much related to images, especially imaging work. So,
sure.
I've got a few short questions for you now. It's quick fire questions, but if you want to take a bit longer about one of the answers, you can. So first, you're at Columbia University, which of course is in the middle of New York City. But do you personally prefer the city, or do you prefer the countryside?
Both. I prefer both, and I'm in a very lucky situation that right now I'm in the countryside. I'm at a house that we have in the Berkshires.
Nice.
And so we have an apartment in New York City, and we have this house here. And of course, we spent most of the time in the last 2 years here at the house for obvious reason. But I mean, the rural environment is really, really fantastic, especially the Berkshires, where you have a little bit of both, because you have a lot of retired people here who are, maybe 60% come from New York City, and so they want to keep an intellectual environment going. So they're very interesting people from all fields of science and arts.
Wow.
And in the Berkshires, you have Tanglewood and Jacob's Pillow and all this. So I love to be here, but at the same time, the urban environment in New York City, this cosmopolitan place, is really wonderful. It's really wonderful for someone who comes from Europe, and it is really more European than Europe, actually, because you have this cross-cultural interaction there.
Yeah, it's like its own little universe. Do you like cooking at all? Do you prepare your own food at home?
Oh, that's an interesting question, because I got I mean, my wife is such a fabulous cook that I can't, touch it.
She won't let you.
No, not you won't let me, but I'm sort of I can't keep up with any like this. So I used to just make myself spaghetti and so forth. But now I just my daughter just gave me very detailed instructions for a certain dish, and so I'm excited to really get into that.
Yeah.
And then I watched. I was forced to watch some of the British show, and
Bake Off, Great British Bake Off.
The Great Bake Off. So they both, my wife and my daughter, watched every single bit of it, and sometimes I sort of saw part of it. It sounded like great fun.
It's very inspirational to see people baking things. Is there any book that you have read recently that you would recommend to people?
Well, the book by Ishiguro is probably very widely known now. So I really enjoyed it. And as you know, he got his Nobel Prize in Literature in 2017. So I got to know him.
Oh, did you meet him in Sweden?
Yeah, that was really fabulous to see him there.
And what about music? Do you listen to music?
Yeah, I really I'm very fond of classical music, and we've been to concerts very often in New York City. And then, but I'm very much a reggae fan. I mean, reggae is so much on my mind that for my 50th birthday, they did a surprise party which was all reggae, on the reggae and Jamaican theme.
That's so funny. I love asking people this. If you were not a scientist, what do you think you would be? Like any other career?
Well, I would really be an artist and writer. I think I never contemplated this kind of career because I thought it's not going to be, only a few people really make it, and the other ones don't really have a very, very good existence. And besides this, my father he had a very negative attitude toward artists. He thought they were sort of parasitic on the society.
Well, now you kind of have both careers in a way because you managed to to get your novels out. We're coming to the end of our episode, you already mentioned this earlier actually when we were talking, but my final question to you was, do you have any advice for researchers who are just starting out in their career?
Well, there's the thing about peripheral vision that I already talked about. There are things that coming up from the wayside, and then you have to not treat them as disturbances, but rather as opportunities to look at other things, open yourself to other influences. And then the other one is that my personal experience with the mentorship in Walter Hoppe's place was that I developed ideas not under his guidance, but in opposition to his guidance. So there were a number of things where I thought I was confronted with opinions that I thought were untenable, and so I give him credit for this. In this environment, I was able to be creative because of the things that I had to contend with. So the advice is then that if you have some really some ideas that you really believe very strongly in, then don't let yourself be talked out of it. Yeah.
That's good advice. Well, thank you very much, Dr. Frank. That brings us to the end of this episode. And thank you, everyone, for listening to or watching this very first episode of CryoTalk. Until next time.
Thank you for listening to CryoTalk, a bite-sized bio podcast sponsored by Thermo Fisher Scientific. To view all audio and video recordings from this series, please visit bitesizebio.com/cryotalk.